Okay, so this is day 11 of the worksheet. So first, we have this world problem. So it says an airplane flies in the direction of 140 degrees at 250 miles per hour, while the wind blows due south at 26 miles per hour. Find the component form of each force, then find the plane's resultant vector and direction. So first, what we have to do is we have to draw the vectors first. So first, we'll do the airplane one. We see that the airplane flies in the direction of 140 degrees at 250 miles per hour. So first we can just make this the one, like the 0 or 360 line, and so we can make it go 140 degrees, and we know that the magnitude equals 250. So this is basically for the airplane vector. So the magnitude is 250 and the degrees is 140. And then the next one is the wind blows due south at 26 miles per hour. So it goes south, and what we do, so north, west, east, south. So this is south, and the magnitude is 26 degrees. And when we see the coordinate plane, we know that this is 0, 360, this is 90, this is 180, and this is 270. So we know that the degree is 270. And the reason why we know this is 140 is because from here to here is this difference is 140 degrees. So this is like our vectors that we have. So in order to do the airplane component form, what we do is that we use the magnitude and the degrees, and then we put it into the formula. So we basically, magnitude 250, cosine, because this is the x, the degree is 140, and we do the same thing except the cosine is now the sine because this is the y part of the component. So in total we have 250 cosine 140, comma 250 sine 140 for the airplane. Next, we need to do the wind component form. So we do the same thing. So we do the magnitude of wind 260, cosine because it's x, 270 because it's the degrees. Again, like 0, 90, 180, 270. And then the same thing for the y except with the sine. So in total we have 26 cosine 270, comma 26 sine 270. So now what we do is to find the this basically like the resultant vector. What we do is that we add these two. So since if we look at this plane, so we can see that this point right here is, it would be on the y-intercept. So we have 0, we go down negative 26, we know that this is 0, negative 26, and then we would add this. So what we have is 250 cosine 140, 25 sine 140, and then we add these two, and then 0, negative 26. So this adding 0 would do nothing, like it would still stay the same. But this 250 sine 40 minus 26, what we would do, we would just write it as that. So now next is we do we find the velocity basically. So what we do is we put it into the formula. So we do square root of this, so 250 cosine 140 parentheses squared plus, this is basically Pythagorean theorem. So we have, and then we have 250 sine 140 minus 26 parentheses squared. So all this squared, which is equal, when we put this in the calculator, we get 234.136. And so we know this would be our velocity, which is basically the magnitude of the resultant vector. And to find the direction, what we would do is we put this formula, which is theta equals tan to the power of negative 1 times b over a. So this b and a would be the y and x. So we have tan negative 1 is 250 sine 140 minus 26 over 250 cosine 40. And when we put this in the calculator, we get that it is negative 35.1201, but it has to be over it has to be a positive answer. It has to be over 1, but this is negative. So what we do is that we add 180 because it can be negative, and we get 144.879. So that would be our direction. That would be our resultant vector's degrees. Okay, so